Assalamualaikum and hi. We are from group 3 and we are going to present about slope remedial technique, which is slope stability. And our group consists of 5 students.
Hi, my name is Abdul Qayyum Ashraf bin Abdul Aziz. My metric card number is CF190227. I want to discuss for introduction for slope failure. Slope failure occur in many forms and there is a wide range in their predictability, rapidity of occurrence and movement, and ground area effect, all of which relate directly to the consequence of failure. There are various classifications of slope failure, but the most useful classification are to employ as their primary criteria the type of movement and the type of slope. Slope in soil and rock are found in nature and in man-made structure. Highway, dams, lifts, canals, stockpiles are constructed by sloping the lateral face of the soil because slopes are generally less expensive than construction wall. As we can see on highway and good construction, a flow slide occurs when internal and external conditions force soil to failure, for to behave like a viscous fluid and flow to even shallow slopes. Spreading out in several directions, flow slide can occur in dry and wet soil. Slope failure are caused in general by natural force, human misjudgment, and activities of burrowing animals. We have 6 types of failure. The firstly, force. Second, toppers. Third, slides. Lateral spread, flows, and lastly is complex.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Salman bin Muhammad Tanuzi. I want to present about literature review. In this literature review, we have technique of slope stability. First technique is soil nailing. Soil nailing technique used to reinforce soil to make it more stable. In this technique, soil is reinforced with slender elements such as reinforcing bar, which are called as nail. The application of soil nailing includes stabilizing an existing retaining wall and excavating retaining structure in urban area for high-rise building and underground facilities. Second technique is shotcrete. Shotcrete is term used for concrete and mortar conveyed through a hose pipe and sprayed at high velocity onto a surface. Shotcrete can be produced by either dry mix or wet mix. Comparison between wet and dry mix method. Wet mix shotcrete involves pumping of previously prepared concrete, typically ready-mix concrete, to the nozzle. In dry mix, processed cement and aggregate are mixed and fed into a mechanical feeder or gun. The third technique is vegetation. In forest slope, vegetation stabilizes slope by providing root strength and by altering the saturation regime of soil water. Vegetation can modify slope stability by mechanically reinforcing slope through plant roots, modifying soil moisture distribution and pore water pressure, adding slope such from the weight of tree and levering and wedging soil by root. The fourth technique is hydroseeding, application of grass seed mixed with fertilizer and nutrient by spraying method over the ground. The application of this method will be considering the soil parameter and agroclimatic condition in project area. As to applying this method, the area that need to be hydroseeded shall be uniform. Minor shaping and uniform spray on rough areas shall be performed in order to provide more effective erosion control. The next technique is turfing. Turfing is a direct application of grass with developed root on a sloped surface. The relatively mature grass will grow easier and extend its root into the soil to section the overall surface. The advantage of this method can be explained as it can be the immediate protection from rain splash, erosion, and reduction of runoff state. The last technique is geometrical method. This is the most common method that has been used in the residential area. This method is usually simple and less costly. The changing of the slope angle from the steep slope to a gentler slope may increase the stabilization of slope, and the angle is usually supported by grass bonding together with soil. Then, for the theory for slope stability analysis is discussed. We will discuss various methods for analysis slope stability and instability. Possibly most important is the fact that mechanical analysis of slope stability provides us with knowledge as to what parameter affect landslide, removing all guesswork and uncertainty. According to soil mechanics, there are 3 types of parameters that determine a slope stability or instability. One group concerns the strength of the soil, another group concerns the geometry of the soil, and another group set of parameters relate to pore water pressure.
Assalamualaikum and hi. My name is Muhammad Fakrul Hadi bin Abdul Rashid, metric number CF100178, and I will present about proposed techniques. Our first method is soil nailing. Soil nailing is a method that implementing using of steel bars and shotcrete to reinforce the ground. One of ground stabilization techniques and the type of slope remedial, which is soil reinforcement. And this method brings soil stability to prevent any collapse from happening where soil nails develop their own reinforcing action through soil nail interaction. It is suitable for an application of ground excavation, and these techniques used for increasing the slope stability and create a gravity retaining wall. At last, these techniques inserting passive reinforcement bars or tendons into pre-drilled hole. Existing ground slope soil include installing spaced steel bars closely with inclination of 10 to 20 degrees with vertical then with a front face support. And these are soil nailing advantages. The first one is cost effective. The second one is effect loss distraction towards traffic. Next is low environmental effect compared to other techniques. Fourth, use less construction materials than ground anchor walls. Next is relatively flexible and can accommodate a large total and different settlements. Next is more efficient in economical factor compared to conventional concrete gravity walls. Next is can adjust the location of nail length and inclination when obstruction encountered. And the last one is shotcrete facing construction is typically less cost needed than other wall systems. And these are the design consideration of soil nailing, where in this process we identify the following factors include strength limit and service limit, vertical and horizontal spacing, height and length, the ground's properties, the nail length and diameter, and lastly the drainage and frost penetration. Then we go to types of soil nailing techniques. The first one is grouted soil nailing. As you can see in the picture, this method works with drill holes on walls or slope face where nails are inserted in the pre-drilled holes, and the hole is filled with concrete or shotcrete as grouted materials, where the range of nail diameter installed from 100 to 200 millimeters with spacing of 1.5 meter. The second one is driven soil nailing, where this method is for temporary stabilization of soil slopes, where this is recognized as the fastest techniques, where it is not provide protection from corrosion to reinforcement steel or nails, and nails are driven in the slope face during excavation, where diameter of nail used is around 19 millimeters to 25 millimeters, which is smaller, and nail spacing is 1 meter to 1.2 meters. Next, this is jet grouted nailing, where jets are used in eroding soil for creating holes in the slope surface, and steel bars are forced into the soil with very high speed using compressed air mechanism and grouted with concrete. This method provides a better corrosion protection for steel bars, which is called as nails. And the last one is launch soil nail, where it's applied by forcing the steel bars into the soil with a high-speed compressed air mechanism in a single shot only. The installation are very fast, but still control over length of bar penetrating the ground is difficult. Reinforce an unstable or potentially unstable soil mass capacity into the sliding soil, and the nail diameter is 38 millimeters and its length is around 6 meters. Okay, now we go to soil nailing installation. The first step is small cut excavation, where it includes trimming slope to perform proposed slope inclination, and the excavate unsupported cut usually is 1 to 2 meter height. Second step is nail hole drilling. This is for installation of soil nail. As you can see at the picture, they're using machine to drill the hole on the slope. We go to the main step, which is the third step, is the installation of soil nails, where they're using machines to install the nails into the slope. And then we go to the place temporary facing, where they're using shotcrete to close the surface for temporary. The next step is subsequent levels construction and perform pull-up test. And this process is to determine the performance of soil nailing based on design working load. And lastly, the final step is final facing on permanent walls, as you can see at the picture on the right side. And last one, we go to soil nailing as best techniques, where these parts will tell us why the soil nailing is the best techniques proposed here. The first factor is soil nailing is an accepted technology, where the theoretical aspects of which are well understood and well reported in technical literature. And proposed here is the installation of soil nail and pressure grouting of nails. This is to overcome to localize failure of the existing slope. And pressure grouting was proposed together with soil nailing, where to ensure the soil nails gain the right anchorage friction. And now we will go through to the second techniques that we propose, that is retaining wall, second firewall. This structure is designed to resist the lateral pressure of soil and hold back soil materials, usually to prevent from sliding or eroding away. It's help control erosion from hard rains or create a terrace yard to reduce maintenance, and intersecting reinforced concrete piles are used to create second pile barriers. The method by using drilling under mud or augering and strengthened with steel rebar or steel beams. The primary piles are installed initially, followed by secondary piles. The average pile overlap is about 3 inches, which is 8 centimeters. And these are the advantages of second firewall. The first one is increased construction alignment and flexibility. The second one is better wall stiffness compared to sheet piles. Next, can be installed in poor soils and difficult ground. Fourth, prevent soil erosion and provide flood control. And lastly, less noise construction. And this is the sequence of design consideration of second firewall. But the first one is design strategy is to increase the wall's structural capabilities in the vertical direction. Primary piles are designed to operate as a leg in between structural secondary piles. Secondary piles are designed to be strong enough to act as vertical beams. For ring compression structures can be also built as second firewalls, and piles are installed in a circular pattern. And then the unreinforced concrete has a high compression capacity. This form of structure is structurally efficient. And lastly, the thrust force acting in the ring opposed soil, groundwater, and surcharge loads. And we will go to the types of second firewall. The first type of second firewall is the tangent type, which is it is built with no overlap and ideally one pile hits the other. It provides the following advantages, which is easier and quicker construction and increased construction alignment flexibility. The second type is hard soft or hard firm. This type of second firewall is the most cost-effective and time-efficient option. The wall is made up of board piles that interlock. A soft cement bentonite mix, usually 1 Newton millimeter square, or firm concrete, typically 10 Newton millimeter square, is used to build primary piles first. The secondary piles, which are made of structural reinforcement concrete, are then put between the primary piles with 150 millimeters interlock. Walls may require a reinforced concrete liner for permanent works application. And next, the hard type. This construction of a hard wall is identical to that of a hard firm wall, except that the major piles are made of stronger concrete and may be reinforced. Secondary piles must be cut using heavy-duty rotary piling rigs equipped with specially designed cutting heads. Finished product has a fully concrete face and can be a good substitute for diaphragm wall construction. And now we go through to the sequence of the second wall installation. The first step is construction of guide wall. This method where the guide wall construct to set up position of second firewall. Next is casing installation. Casing is driven using vibro hammer into the ground. 1 meter length of casing protruding from ground is lifted. Third step is augering of primary boreholes, where a drilling tool named auger that cuts and removes the soil within the casing to form a primary boreholes. Next, concreting of primary boreholes, where the concrete is poured into borehole to form a primary bore pipe. Next, we go to augering of secondary borehole. This step is done after casing of 2 primary bore piles are extracted by vibro hammer, where the auger cuts and removes the soil in between the 2 primary bore piles to form a secondary borehole. Secondary borehole intersects with the adjacent primary bore pile. The next step is steel cage installation, where the steel cage is lifted up by crane and placed within the secondary borehole. And the last step for the installation is concreting of secondary borehole, where the concrete is poured into the borehole to form the secondary bore pipe. And lastly, we go through to the second firewall as best techniques, where this part will tell us why the second firewall is one of the best techniques that we are proposed. By using the right drilling equipment and methods can achieve installation tolerance and allow a second pile shoring system to be employed in geotechnical conditions and at depth previously thought to be impossible. Laid without the noise and vibration associated with driven sheet piles, and lastly, allowing high capacity retaining structures to be built near existing buildings that are noise and vibration sensitive.
Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good day. My name is Muhammad Hasanuddin bin Muhammad Kawan, and my metric number is CF190125. Okay, so for now, I'm going to explain about the application of any standards for the methods or techniques that we propose in this project. Basically, for this project, we apply 3 standards, which is the first one is the JKR guidelines, the second one is BS 8006-2008, and the last one is SCL 318-08-2008. That was the standards that we applied for both methods that we propose. Done for that, I'm going to explain for the first standard, which is JKR guidelines for slope design, specifically for the factor of safety, FOS. Okay, as you can see on the slide, there are 3 points there, but there are 2 points that I will explain in details. Okay, the first one is we can see as we need to implement the slope limiter techniques, it is concerned to know the factor of safety as to prevent the slope failure. It is mean this factor of safety is really important, it's really crucial for the slope failure itself. Okay, the second one, you need to know this acceptable or the higher factor of safety nowadays will exist as to find the way how to remediate the failure or unstable slope. Okay, this acceptable FOS is actually found out by previous geotechnical engineer so that they can remediate the unstable slope or the failure slope. Okay, the third point is actually mentioned about the table 1 that shows some of the minimum factor of safety depends on the condition, which I will explain after this. Yeah, there you are, the table 1 that I mentioned earlier. Okay, this is the table 1. It shows the typical geotechnical design criteria. Okay, as you can see to the table, there are 2 design components, which is the first one is unreinforced slope and the second one is reinforced or treated slopes, but not on soft ground. For both design component, there are 2 mode of failure. It's okay, I will explain for the first design component. Okay, as you can see for the unreinforced slope, there are cut and fill slope and the bearing fill. Both minimum factor of safety are different, which is the cut and fill slope is 1.3 and the bearing fill is 2. Okay, let's go for the second row, which is reinforced or treated slopes. They have the same mode of failure as unreinforced slope, but if you can see what the difference, they have different minimum factor of safety if we compare for the unreinforced slope, but for both mode of failure for the reinforced, they have minimum factor of safety, which is 1.5. Okay, now we're going to the second standard, which is BS 8006 1995. For this standard, it's actually for the analysis of substability for the soil nailing method. Okay, this standard is applicable to use for the soil nailing design as recommended by BS 8006. There are two methods that can be used to analyze this technique, which are two-part ridge and the log spiral method. From both methods, it is highlighted that log spiral approach reasonable agreement with actual structure, and this log spiral method also have convenient calculation to determine the shear or tension in nails. Okay, now on this slide, you will see two figures of analysis, which is the first one. In the left one, you can see two-part wedge analysis, and the right one is log spiral analysis, where it is used for analyze the soil nailing design. Okay, as we know, for the factor of safety reference for the method in BSX 006, there are limit state LS principles. As we can see there, as for soil nailing, it requires minimal risk of ultimate limit state ULS and serviceability limit state SLS. For both that, there are some things need to be considered, which are ULS that need to be considered are external stability, internal stability, and compound stability. While for the SLS that need to be considered are external stability and internal stability. Okay, as you can see here, this is the example for the ultimate limit state and the serviceability limit state. As I mentioned, there are external stability, internal stability, and compound stability. You can see for the ultimate limit state ULS. Okay, for the first one is bearing and tip failure. It was external stability. Second, tension failure of reinforcement, internal stability. And the last one, for the compound stability, the example that shows is tensile failure of reinforcement. Okay, we go for the second one, which is serviceability limit state SLS. There are two examples because there are only two stability that we need to consider, which is the first one external and the second one internal. For the external is settlement of slope foundation, and the second one is both construction strain in reinforcement. Okay, now this is the last standard, which is SCL 31808 2008 for secant firewall design consideration. Okay, in this standard, it's actually typical design approach develops the structural capacity of the wall in vertical direction. The second firewall consists two piles, which is primary piles unreinforced and secondary piles reinforced with a wide branch or river catch. Second firewall also designed as ring compression structures as to make it able to install in circular configuration to resist the loads in circumferential compression. And by the standard, it is able to compute the compression strength of unreinforced ring, but not for the buckling capacity. And now this is the design for the second wall that you can see there. There is how the second wall was installed in the soil for remediate the soil failure.
Hi and Assalamualaikum. My name is Muhammad bin Nadi and my metric card number is KF190068. I want to present for the slide is long-term stability for the purpose technique. There are two purpose techniques that I choose from the title. So the first is stability analysis on slope. A major impact on real slope stability evolution in metal suppression method can be attributed to change in slope soil resistance caused by the operation of static or dynamic load on the slope. They have several factors influence the effect of landfall on soil water content. These include soil characteristics and topography, rainfall volume and intensity, land cover, and soil water content conditions immediately before and immediately after rainfall. Now continue, this is number 2, slope monitoring. In order to keep the slope sustainability, slope monitoring must be done regularly to ensure if there are any change or movement of soil at the slope area. For an example of slope monitoring, after the landslide tragedy in Bukit Antarabangsa from Srila Harian 31 May 2020, this figure gives about the landslide at Bukit Antarabangsa from Srila Harian. Okay, that's all for my presentation. So, thank you.
For the conclusion in this project, an economic analysis performed on Bukit Antarabangsa in Selangor as well as on other soil nailing and section firewall structure indicates that this technology lead to cost reduction of about 30%. In relation to classical methods, soil nailing and section file is presently commonly used to stabilize retaining walls in the restoration of all structure and building that are located in various soil condition. Soil nailing and section pile applied to existing masonry structures such as failing retaining walls abutment provide long-term stability without minus demolition and rehabilitation costs. This technology, as the stability analysis has shown, ensures similar global factor of safety in comparison to FLAW 1.